Hello, everyone. My name is Mads Barami from Wolfram Research. Welcome to the third session of our live coding series with Mitch Stonehocker. Mitch will do live demonstration of key features of Wolfram language that are useful in building Wolfram Cloud APIs to JavaScript front end and serverless backends. If you are joining us for the first time, Mitch has been using Wolfram language for more than 30 years. His work experience is quantitative and operational financial markets. Most recently, Mitch has been using Mathematica, Wolfram Cloud, JavaScript, AWS to set up ChristyHealth.org and other websites. During the first session, Mitch focused on JSON and images. For the second session, he discussed more complex JSON, calling external services using Wolfram Cloud for storage and images. Today, Mitch will discuss how to make dynamic images and with Wolfram Cloud for JavaScript front ends. Without further ado, let us welcome our instructor, Mitch.
Thanks, Mads, and welcome everyone. By way of review, in session number 2, we left off at creating these graphics. And so we're already into creating dynamic graphics. So for example, all you have to do is update these fields. Update these fields. Go up there and you can see that the graphics are dynamically updated. Again, I showed sort of just update these, and you see how fast the API is coming back, given that this is something that that Wolfram is computing, generating the graph, and in this case, generating 4 different kinds of graphics and sending them all back. So you've gotten your first taste of dynamic graphics, and a couple of considerations to think about as we go forward. So what I'm going to be doing in the next couple of steps today is, first of all, there are some utilities functions that I've built for myself and grown accustomed to. So I'm going to introduce those a little bit. It kind of, for me, it makes it easier to assemble these APIs. As you have seen in some of the earlier APIs that we built, the function block, what I call the function block, can get pretty involved, especially when you're calling out to external APIs, or you're dealing with some sort of internal storage, or let alone if you're having to do some statistical analysis inside that function block on data that you've had to bring in from external sources, and then you've got to save something to an external source before you present the image or the table or whatever it is that we're going to be sending back in either in JSON or as an IMG dynamic URL. The point of all of that is the function blocks inside these APIs can be very involved. And so I'm going to, first of all, I'm going to step through, I'm just going to copy over and step through what I mean by a function block. So, or excuse me, an API sort of, a make API helper function. So as I've introduced from the very, very beginning, the API function has 3 primary parts that we have to deal with. One is the arguments that go into the API, and those arguments are being sent to us on that API string from the JS front end, or from any front end. Then is the function block, and as I was just indicating, that these function blocks can be very involved, and can be many, many, many lines of code. And so, as you will see, particularly as we get into some of the APIs that we're going to be making here in this session, I like to step myself into, first of all, I like to build the functions outside of the API function, outside of this API, because there's sometimes I don't exactly know how I'm going to solve what needs to be solved. So I have to, build the solution outside of this whole API function construct. And once I'm satisfied, then I know how to build the function, and I have to start building the pieces of the function. And I do that generally in a very modular way. And I put the modular pieces into the function block and make sure that this API function construct is working before I put the entire function block code set into there. And I'll step you through that example. And then, of course, there's always the formatting that goes along with it. But after that, then we have to cloud deploy all of this. And so there's a number of things that go on with the cloud deploy. For example, defining what the endpoint, what the name of the endpoint is going to be, and the name of the function that we're going to use as part of that endpoint. And of course, we're passing to the cloud deploy our API function. Of course, we're setting permissions, and as I'm going to be doing through all of these sessions, I'm just going to set permissions to public. Although not good practice. Certainly not good practice for production. And at some point, I'll have to come in here and talk about this, but not today. All right, so that's where we are right now. So what I want to do is again, before I get into any sort of coding, I'm just going to again rehearse for you how this general approach is going to work. So I've got the arguments. X is interpreted as an integer, Y is interpreted as an integer, a random function. This is the API that we've already seen before, and the format is going to be JSON, and so the parameters are going to be X's from -10 and Y to 10, and we're just going to be able to run that, and it's that simple. All right. So and from that point, then at that point, then we have the cloud deploy, and all we're doing is defining the endpoint, the function name, and what the permission level is. And by running that, we now have our API off and running, and we could build this, or we could define the session and web execute that if we wanted to in exactly the same way as you've seen in the prior sessions. I won't bother with that, but you can start to see how having this helper function, right, and being able to define everything that goes into the make API function, have everything defined outside of that, is going to, I think, help us in keeping that idea of modular development and testing the modules individually and separately. We'll step through that. But as a warm-up session, I thought that I would go back to our get it function, which is reaching out to a placeholder website, which produces standard JSON for working with, and so I'm going to start with a clear all, and I'm going to define 3 arguments. One is it, one is n, as in the number of things we want to return, and one is something called locations. And so right now I'm going to define it as users, n as it doesn't matter. I'm just going to say 4 users. And then location gets a little bit interesting, because what we want to do is we want to go use a standard Mathematica function called geoposition. And what we're going to do is we're going to say, I guess maybe what I should do is, or the way that when I develop these things, I always start with the data that I'm going to be working with, and so that's going to be get. Right, that's that. Remember, the get function is the function we made last time, which is calling that external URL, and it is already defined here below us, and we have not cleared it. So I'm just going to run that and see what we get. And sure enough, it's we'll wrap data set around that. Okay, it's that set of users that we've seen prior, and you'll remember how we went down and got the geo. Slide over. Actually, maybe I should expand that out, and we went down at one point and got the address geo branch, got the latitude and longitude. So we're going to do the same thing here, and so I'm just going to wrap this the other way. It'll be more convenient for us. So we've got the data set, and what we want to do then is we want n number of, and now we have to go down the data set branch address, geo, and lat, and what is it, LNG. That's how they do longitude. A little bit strange, but anyway. All right, so that's what we're after there, except that we don't want, we want to put this just into a list of pairs here. All right, so we want to get rid of the key headers, so we can, that's easy to do just by doing something like this. Okay, so there we go. That's easily done. And now the other thing that I really want to do is I just want to pass a list there, not an association. And so there we go. We have a list of lists. Okay, and the lists are the longitudes. All right, so that's pretty good. Now, if we just put that inside of geoposition, then what we're going to find is we have our locations that we're after. Oh, I'm sorry. I hope I didn't kill myself. Let me just sort of abort that, because what I need to do is I need to do a little bit more operating on that. So what I'm going to do, so those numbers are strings coming back, right? Expression. That's what helped me remember that there was more work to do. Okay, so we've got our list of lists, and hopefully you're familiar with this notation. This is the apply notation, and it is apply this data, right? And this is the function notation, and this is the function we want to apply to, and there's the slot, all right? So hopefully that should work out better. Fetch URL placeholder server 404 not found. That's not a good thing. Let me make sure. Let me make sure. Because we have our code function right there. Okay. Let's just first of all, let me move. I'm gonna clear this because we're not going to use any of this anymore. That was just for sort of warm up. So if we have get, well, I know that worked because that was get, so that was fine. Okay. And data set normal. Yep. Okay. Okay. To expression geoposition. That should work. That should work. Yeah. That's working too hard. Why is that working so hard? Oops, export that again. I have everything that I need. Yes, that's done. Yes. Well, don't tell me my first example is going to break on me. I don't know why that's. That's not very fun. Let me just try. try this. Well, this is where I hesitate to try and get in here and debug it, because that could take, I don't know, minutes, and I don't want to waste your minutes. On the other hand, something is definitely not right. So let me do this. I'm just going to copy over the copy paste the executing. All right, so I'm not exactly sure why this is not coming up here. You can see that the geoposition stuff is happening here, being passed into a variable called locations, and then I'm going over to the geographics, right? And I'm using locations to create a geopath, make that geodesic, and I'm using geomarker on locations to create this entire geographics inside the geographics, and then I want to use that over the geo range of world, and we'll project on a Robinson worldview scheme. All right, so sorry about that. I don't know why that failed. I'll have to figure it out. But at this point, then, what we can do coming down here is we can say, well, all right, so I want args to be equal to, here, change that. I want args to be equal to the it value has to be a string, okay, and the n value has to be, I'm just going to use string again, just for the fun of it. This could be number, could be integer if you wanted to really restrict things. So func, I'm going to say, is equal to, and because, and so here's everything that has to go into the function. Locations has to be calculated as part of the functions. Okay. This is also why in a lot of times you'll see me use the function in defining this, as opposed to the sort of curly, that the ampersand at the end of a function block that a lot of people use as a sort of a shortcut. So we've got our location defined. We know that the geographics is all one function block, or all one sub-function block. So these are the two components, right? Component number one is going out to an external site, getting users and making a data set. And from that data set, we're going down the address and geo branch to the lat longitude. We're extracting the values. We're normalizing that into a list of lists. We're making sure that everything in here is an expression, so there's no strings in there. And we're operating geoposition across that to create a variable called location. And then with locations, we're using locations multiple times inside geographics to produce what we want. And then the last thing that we need is a format function, and what we're going to return here. Let me close that off so that doesn't show. What we're going to use here is just a PNG. All right. Now at that point, it's as easy as parameterizing our make function, our make API call with our three parameters here, and then passing in our three arguments here, and then we have to make our params argument here, which is going to be, and I'm just going to really cheat here a little bit by doing this and saying that this actually goes to users. Users, and this is going to be, I don't know, 3. And if we have everything, args, typo there. Okay, if we have everything, we have a fail, n, because n. Oh, I see. So this is another. This is how you go about debugging it, right? So n has to be put into, you know, functional form, slot form, where the name of that slot is n. So it actually knows then to go out and look for its parameter out there. And that still didn't work. Why didn't it work? Is n fails contain validation. What maybe I do need to do that as a number because I'm not passing it. Oh my, I'm really off to a bad start here. So here's what I'm going to do. So this clear all is going to clear all of this, right? We have the IT string there. It passes the string too, although, see, I do use a to expression there. Okay, all right. But anyway, we're off to good. Okay, so there you go. We've got the image in good form, and given that we're already 20 minutes into this, and it's a lot longer than I expected, we're going to pass in here. We're going to pass in here our endpoint live. Our endpoint being a live coding session, the function name being geopins, and the fact that permissions is public. We're going to pass that into our make cloud deploy, make cloud deploy function. That'll fill out these two arguments. Pass the parameters in there. We're going to kick off a session. And that session is going to pass that URL that we're building. So over here on this screen is where my Chrome browser opens up all the time. And voila, there's a PNG file for us ready to go. So we've just done a little bit of mocking up, testing, put the function together, and the JSON code that goes along with that is actually very, very simple. And I want to point out a couple of things about it before we go into the next more complicated image rendering in the front end. And that is that this IMG tag is just sort of out there by itself. And you can see that everything is being dynamically updated on its own. And in fact, you can see that I'm not even wrapping, I don't even have a form in any of this HTML. So there's no controls whatsoever from the HTML side. And as you can see on the web page, no controls. This is the printout of the important API code that we're after, and we do get the image in the HTML. So that's one of the ways to go about it. This is what I would call a static, but a static server, right, rendered image, because there's no form controls here that are managing this image, right? Everything is, for all intents and purposes, hard-coded here. Now, we could, of course, create form controls that allow us to play with these variables and then update those arguments in the API. But that's what we're going to do in the next session. This next session is going to, or this next part is going to be a little bit heavier lift, and so hopefully I can work out my typing bugs and not have these kinds of typing issues. Nevertheless, we'll get through it. So what I want to get into now is and this is API 10. What I want to get into now. Second, let me. Okay. API 10. API 10, what I want to get into now are some considerations about image size and aspect ratio that goes on with images, because what you're what you can see in both of these image instances is that I've made no effort to describe what the size or what the aspect ratio of any of the returning graphics should be. And of course, this is really an important consideration when, particularly if the front end guys are telling you this is the aspect ratio and this is the image size that you have to play with in the HTML. But it's also, it can be also important on the other side, which is if I'm spending a lot of time on Mathematica building a really pretty image, then I would like to be able to say to the front end guys, oh, in order for this image to show the specific kinds of details that we need to show, then the image size needs to be thus and such, and the aspect ratio is best if it's whatever. All right. So some consideration with regard to the back and forth that happens from the Mathematica side and the JS side in order to accommodate what kind of image sizing and aspect ratios we can deal with. So there's a couple of options. Well, a couple things. So Mathematica will return in good form for the IMG tag kind of items, both image items that will return in Mathematica world, an image head or a graphics head. So we'll be able to know in short order exactly how to deal with objects, Mathematica objects that return heads of graphics or images. But you realize that there's a lot in Mathematica that are returning heads other than graphics or image. And so the question will become, in pretty soon here, the question is going to become, can I make, for example, something can I make a grid, which is going to return the head grid? Can I make that an image? Fortunately, the answer is yes. And I'll step you through how we're going to go through that. The key consideration before I get too far down the road here is that three options to images and graphics and some of the other techniques that I'm going to show you are image size, aspect ratio, and raster size. All right. So keep those options in mind. And if you're on the Mathematica help page, maybe go ahead and do a little lookup. When it comes to image size, in Mathematica world, image size works out to about 72 what are called printer points per inch. And so this becomes interesting because it turns out that we are going to be able to come up here, Windows toolbar, and open up a ruler, and we're going to be able to actually measure whether something is the number of inches that we want it to be. All right, so that's going to be number one important helper, because again, the front end JavaScript guys may say, well, you've got a 3-inch width that you can play with here, or a 4-inch width that you can play with here, and height may not be a factor for you. So at that point, or they may tell you, well, you've got a 3-inch width and this kind of an aspect ratio. So whatever you can fit in there. Okay, so what does that mean what does that mean the height needs to be, right? So there's a lot of these questions that can come up as you go through this, and a couple of the common aspect ratios are 21 to 9. That is to say, 21 as a width and 9 as a height. Another common one is 16 to 9. Another common one is 4 to 3, and of course a 1 to 1. So we're going to play around with all of these, and the one consideration before we get actually into coding that I'm just going to copy from some of my notes here is that a typical IMG tag is going to have some SRC method from which you're going to put some image. Now, this image here is just expressed as a GIF file, which may have been stored locally, but you can see how I'm operating on these SRCs as a full-on URL to a server location, and those URLs can be dynamic, kicking off a re-render of the IMG tag at all times. The alt is, I'm not going to spend much time describing that. It's just it's a backup for if the SRG resource fails, what are you going to do? And then there are two ways to go to go about actually defining the width and the height in HTML terms. One is to explicitly call the width method and the height method and explicitly set them. Another is to use a style inside a style method to define explicitly in what turns out to be more or less a JSON format, that is to say a key and a value format, what the width and the height is going to be, and then do something like explicitly set the number of pixels that you want the height and width to be. So these are some of the considerations that we're going to be working through. And so what I want to do now is I just want to define or just work through a couple of steps that we want to think about as we go through here. All right, so if I do, I'm just going to say, it's my habit again, plot DI and NDI. All right, so if I set DI equal to 72 and I say NDI equals 3, then what I'm really after here is I'm saying, well, if there's 72 printer points per inch, then I want 3 inches. You see, okay, so we'll get there in a second. And then what I want to do is I want to take a very standard plot right out of the Mathematica help section and name this thing plot, right? And what we can see is that I can work with this option called image size and the option called aspect ratio. And if we run this, we get something like that. Now, it turns out that there are a couple of measuring functions that we can use here. And I'm going to put this down here because I'm going to inject some more code. So we can actually extract out the image dimensions, the aspect ratio, and in this case, all I'm doing with the aspect ratio is I'm just putting it in real terms. Here we're right. So this is the first thing that I want you to notice. First of all, if the aspect ratio is defined as 1 in this plot function, but it's not 1 down here, then, well, what are we doing wrong, right? On the other hand, 3 times 72 works out to be, well, that's 216. Okay, well, that works. Now, is this image 3 inches long? Well, if we kind of come up here and just sort of eyeball it, it looks like it might be sort of close to 3 inches. But, how can we do both a better eyeballing and get a little bit more precise about what we're doing? Well, one of the things that I've come to do is I've come to wrap PLT in Frame, and I'm going to, because I'm looking at my time, I'm going to just copy paste a couple of options that I always use. Oops, and I missed the first letter there. That I always use when I go about this exercise. So I want to set the frame margins explicitly to 0, and I do that because the default frame things that are framed, the default margins are not 0. So now I'm setting them to 0. I'm setting the content padding to 0, and I just want to put a frame style of gray around it. Okay, so let me close that off. All right, so now we can come up here and we can say, yeah, that's looking pretty close to 3 inches. But nevertheless, we don't have this aspect ratio quite right. So what's the playing around that we have to do in order to get that right? And that's where I'm going to come into step 2. And step 2 is to look at the so step 2 is to do a couple of things. So first of all, what I want to do is I want to explicitly call, I want to explicitly create a variable that I call XPX, which is the x-axis printer points, and I want that to be, and I'm just going to take this out. I want that to be equal to this, and I'll show you why in just a second, right? Now, number one, I want that to be the case, but I also because now that we've defined the x points, right? I want to be able to define the y points. I want to be able to define something called the y points, because in this exercise, the thing that is off is our ratio of x to y. We want it to have a ratio of x to y to be 1, right? But it's clearly not 1 here. So let's see if we can force it to be 1. And what do we need to do in order to force it to be 1? So one of the other things that I can do is I can say, well, I want the x part, or in other words, the width part of the aspect ratio to be 1, and I want the y part of the aspect ratio to be 1 as well. So let me put these up here in the clear all as well. Okay. Now the relationship between x and y then is just going to be this. It's just going to be xpx times, I guess I don't need to do the parentheses, but whatever, YAR divided by XAR. Okay. Now the interesting thing is in my image size here, if I explicitly set the X dimension and the Y dimension, and then this may seem a little bit redundant, but I'm going to do it anyway, because as we start playing around with different aspect ratios, it's going to be important. Let's get the aspect ratio of xy over y over x, and voila! And oh, look at that, 216 by 216 with the aspect ratios of 1, and we know that 216 is 72 times 3. That's exactly what we're after. And sure enough, wow, that looks really, really close to 3 inches, even though that's an eyeball kind of an operation. So I think we've got this under control, which is a real nice thing. So I see an opportunity for another utility function to come in here, and that is dealing with all of this, X ratio part, Y ratio part, and the XPX and the YPX. That is to say, what are the size, and so you can start to see what the relationship is between the size of what you want relative to the aspect ratio that you're going to be dealing with. Okay, and so this okay. So let me do a little bit more explaining of why I would do something like, well, why do you? Isn't this a little bit redundant, right? You have an argument and you're just giving back the argument. Well, yes, except that when you start to get into into deeper levels of functions, then you may not know whether you're getting just a base for our WPX function, or whether you're getting a base, a width, and a height, which is telling us what the ratio, what the ratio based, or what the ratio adjusted, right, width needs to be. And on the other hand, if you know the base in H terms, in height terms, then you're just going to pass that base. But if you if what you're being passed, which is exactly what we were doing up here, if what you're being passed is, well, I know the X size dimension and I know the ratio, so just give me the Y size dimension, right? So that's what all of this is doing here. So so when you're operating in general terms, you never know whether you're necessarily going to get just the base, or if you're going to get the base and the aspect ratio, or the two components of the aspect ratio. But if you get the base and the two aspect of the and the two parts of the aspect ratio, then you know exactly how to compute it. And so here's the little sort of test case. So if I'm given the width as the base, right? If I'm giving the width as the base, then what should my height be given these parts of the aspect ratio? Well, the height should be 81. All right, and that would turn out to be the fractional part of the aspect ratio in real terms. And on the other hand, if I know what the height size is, and I only know the aspect ratio parts, then what should my width be? And there we go. If the height is if the height is 72 times 2, then given the width and the ratio, I should be at the, yes, 144. Okay, so you're going to start seeing these functions inside the code, the code as I start going forward. So at least now you know what's going on with it. All right, so I'm going to set up now a way in which we can just sort of play around with these concepts a little bit, just by, oops, there we go. It's these two. Let me get that in there. Okay. So if we put this in terms of our prior function that we were playing around with plotting before, and what we can do then is we can say to ourselves, well, we can play around with these aspect ratios and make sure that our aspect ratios are coming out 3 to 4, 75, which is what we expect, 3 over 4 to be, and the pixel, not the pixel, but the printer point dimensions are 200 by 150. That's exactly what we're expecting. If we have, a 16 and a 9, then you can see exactly what's going on to the size and the aspect ratio of the image. And if we want, I want that to be 400, then so hopefully you're starting to see that we can have complete control over both the aspect ratio and the size of the image that we're playing around with. And so there's one more piece to this. And again, because I continue to be amazed at how fast time goes by when I'm working this. So I'm going to copy paste this. We've already seen how I've got these 3 variables, right? Here's the printer points. I'm just explicitly putting them. Here's the number of inches. Here's the ratio width height that I'm after. This is the plot function that I'm after. And the only difference here now is that I'm filling in, you saw what we were doing with aspect ratio and image size, and you can see that I'm now using the functions that we've defined prior. And the rest of this is simply styling. For example, I just want to add the label. I want to frame it. I want to have frame ticks on both the x-axis, the left x-axis, on the bottom x-axis and on the left y-axis. And here's how I want to style the frame ticks, and et cetera, et cetera. And then we're going to calculate plot. Sorry about that beep in the background. There's storms on the East Coast, and for whatever reason, in the last few years, whenever it rains, we get storm alerts. I don't know. It didn't used to be that way. At any rate, so you can see now some of the habits that I get into as I work through, creating the size, the scale, the ratios, and making sure that everything is going to fit, right? So the Y left and right axis, the X top and bottom points, a plot label, and to make sure that we're coming out in the printer point amounts that we're after with the aspect ratio that we're after, and we are good to go. So at this point, that was for illustration. I'm not going to create an API out of this because I got something in mind that's a little bit more to it than this. So what I want to do now is, and again, for sake of time, and because typing this takes longer than explaining it, and I have a hard time explaining and typing as I go. Anyway, I'm going to create this really easy and very arbitrary function, which Mathematica, and then we're going to get the head of that, and then we're going to look at the full form of it. Which Mathematica produces this and puts that in a really nice, formatted way. It looks very mathematical and pretty cool. So this is the full form of that thing, right? Now, the thing that we can do, because we've seen that we can use framed to highlight, in this case with a light red color, to highlight the size of this thing, right? So we can see that Mathematica is looking, maybe that's a little bit too light for online video. There you go. So you see that Mathematica is putting some size and dimensionality aspect ratio around this thing automatically, right? So that's really good and helpful information to have when we go about doing this. However, you can see that the head of this thing is not an image, or a graphic, and therefore we're going to be really stuck trying to do that on this equation. So we've got to do something else to this. And what are we going to do? Well, what we're going to do is we're going to rasterize this. And so if none of you, so for those of you are not aware of raster, first of all, the Mathematica help page does a good job of explaining exactly what's going on with rasterize. But really what's going on with rasterize is it's creating a mapping of, what bits are where, right? So it's basically turning something, whatever it is, into an image file. That's sort of the simple terms, the way that I think of it. So we have this framed object of the equation, and we're going to rasterize it. And okay, we've rasterized it. So I'm not going to get into the reasons right now. I will later. Why this looks not so good here? I mean, we wouldn't want to push that image over to the web, and we'll clean that up in just a few minutes here. But you're already getting what the printer point size is and what the aspect ratios are on this image. So you already have a starting point of what Mathematica returns to you. What's the size of it, and what's the aspect ratio of it? All right, so that's a good starting point, but it's certainly not where we want to end up with, because again, we want to clean up this we want to clean up this the rasterization here and put it in a much clearer, a much more focused way, to get it looking like this up here. Okay, so we'll get there. All right, so now at this point, though, the thing that I want to do, it turns out, okay, so sorry for jumping around here, but I'm starting to become really conscious of time. The interesting thing is that framed takes an option called image size. And this is really, really helpful. So actually, let me just do this. We saw that was 111, so let's call it 200 by 100. All right, so you can see that by applying this image size to the framed object, we're changing how Mathematica is rendering the rasterized item. Fortunately, there's also alignment goes to center. Oh, I know. I'm sorry. Let me do this. I didn't put the alignment in the right place here, so give me the alignment is a argument, or is an option for framed as well. So now we can come in here and we can make sure that this equation that is inside framed is centered both on the x and the y axis. And now we framed that, so and we can see what the dimensionality is, And we can see that, well, it turns out that we have 200 by 102, which is not quite there. And we have the aspect ratio that we were looking for. I won't get into why that's off by a tick, but I know why that's off by a tick. So if we were to come down here and add in our parameters, then you'll remember we've got 72 printer points per inch, 2 inches, an aspect ratio where the width is 16, the height is 9. I'm going to apply a font size argument to the font size that's in this equation, and I'm going to style the equation so that there's a font family, font size, and I'm going to apply. I'm going to wrap that in an item where alignment is centered, which is just another way of saying that. Well, I won't get into it. Item is a container that works really well inside framed things, inside column things, row things, and grid things, and et cetera, et cetera. It's pretty handy. And then this RS multiple is, well, how many times do I want to amplify the printer points, right? So in other words, right? So we want 72. We want 2 inches of actual size. Oops, that's a little bit big. 2 inches of actual size. Why is that coming out so big? And we want to multiply our printer point width by some rasterization level. This is much bigger than I anticipated. I'm not sure. I've probably introduced some bug, in here. So I'm not going to stress about it right now. But you can see, even with the size of it, that there's some improvement on the rasterization that can happen here. But this is a much better rasterization than was happening before. And we do, in fact, have our aspect ratio that we're after. All this, the sizing isn't exactly what I'm after. All right. Now, as we carry on with this, then I'm going to get a little bit trickier and introduce another equation here. And what we get here is we get 2 answers to this solve equation, right? Two possible solutions to this solve equation. And in this case, EQ returns as a list, and in fact, we have to drill down some in order to get into the body of the list. So, for example, we have to go the first level, the second level, the third level, and we would expect to get that X out of there right there. And sure enough, if we do head on that, then that's a symbol. Well, it turns out, without going too far into all of this and having the API blow up because it's trying to process on a symbol and it doesn't know how to process on a symbol, what we want to do is we want to introduce the idea that when we're operating on equations like this, we want to prepare, we want to first, we want to be able to, first of all, work on the styling of whatever is going on here. So in this case, black, italic, and a 24 font, right? You can see that all I'm doing is passing the various pieces of the block, that equation, through this styling, and I've now performed that styling. But what we're also after, okay. What I'm also after then Actually, I'm gonna hold off on that. Wow. I'm already really cutting to the end of my time here, unfortunately. So I'm going to be really, really fast about this because I want to at least get this far. All right. So we're setting ourselves up here. There's a lot of variables that go into all of this. How many printer points do you want? What's the height and width? As you start to get into this can get wrapped in grid, right? So as you start to get into grid containers full of stuff that have to be rasterized, then we're going to start to face the problem of spacing between elements or items inside the grid. And so we're going to have to deal with that. And that's where this X left and X right, that is to say on the X axis, what's the leftmost spacing, what's the rightmost spacing. On the Y, there's the top, center, and bottom. What do those spacings need to be? Do I want to manage the fonts inside of this? And here's the raster size multiple that we're going to deal with. So what I'm doing here, a little bit of overkill, but nevertheless, to be able to help you see all of the variables that have a play in how, and once we want to rasterize something, all of the sort of spacings and dimensioning of all of the elements that are going to go into all of this, how they can play into this. So what we're going to do now is we're going to take this equation, run it through our styling. We're going to introduce our spacings inside the grid. We're going to frame the grid in a certain grid style so that we can see just the spacings that's happening on the grid. And then we're going to pass that grid through a styling operation on its own inside the framed. And then we're going to pass our image sizing that happens on the framed object plus any of the margins, et cetera. So you can start to see how you can start with a really small kind of thing, a small, what you might think is a small idea, but there is just a lot going on. So here's the dotted lines, right, but that happen on the grid item, including the fact that in the grid item, on the grid item, I'm actually introducing a spacing element on between the two items, that is to say, spacing on the center item of 1, which if I come down here and I say, well, give me a spacing of 5, what does that do? And you'll see right away, well, that's what that's doing is that's moving the spacing of these elements much farther apart in the grid. And when by the time you get that into the defined frame space, you can see that's moving the two elements outside of the frame space. And of course, when you rasterize it, well, there you go. So you can start to see the interplay that happens, and some of the relationships that you are going to have to play around with as you get into getting yourself ready. And so you can, and when we pass the head of the grid, the head of the frame, and the head of the raster down here, you can see what we're dealing with. We're dealing with the grid first. That grid is framed. Aha, there's our image. And now we're looking at the pixel quantity per the height, the pixel quantity per the the pixel quantity per the width, the pixel quantity for the height, what that ratio is, and that's a 0.562 ratio, which given we are 16 to 9, that's exactly the fractional form of that aspect ratio that I'm looking for. And this is a good form image. That image is ready to go and show up in every good form as what we're looking at here. And that's what we're going to do when we come back next. There's going to be a 4th session. I'm sorry to say, but happy to say, because we have more to do here, and there's more combining to do. And when you get in here, what you can start to see on the web page, and one of the reasons why I went to the extent of defining out all of these parameters is because in this case I've built a HTML control for each one of these parameters. So if you want to click off the frame grid, there you go, or the image grid, or I want that. or what happens when I change the font size to 15? What happens if I want the raster multiple to go to 20? Does that improve the image quality? What happens if I want to introduce a center spacing of 3, right? Or if I want the base pixels to be 400, right? So there's a lot. So you can start to see the interaction that's happening on the Mathematica side relative to the HTML side. They put that, add that in there. And you can start to see the relationship between the two. All right, so at this point, are there any questions?
There was only one comment,
Okay.
one of our users mentioned that, regarding, aspect ratio, you can use also the option image padding.
Yes.
Of course, you need to know the image padding. So that was one comment.
Exactly correct. That's exactly correct. And whatever your comfort level is on some of these things, I tend to use, I have, as a matter of habit, I've started to use frame precisely because I like to be able, especially when I'm starting to package and put these things together, to be able to say, well, I want to know where the frame is, and it becomes easy to see where the frame is when you've colored it somehow, right?
So that was the only question. So I think that's a very good point to wrap up our today's session. You were watching the third live coding session with Mitch Stonehocker. You can find the recorded videos on Wolfram YouTube channel. Let us thank Mitch for the great lecture. Thanks for watching and have a good one.
Thanks, everyone.